Now, let's move on to the full mean value theorem. The mean value theorem, or MVT, is a bigger and more general version of Rolle's theorem. Before, Rolle's theorem only worked when the endpoints had the same value. Now, we remove that restriction. So the function does not have to start and end at the same height. Here's the main idea. There is at least one point where the instantaneous rate of change equals the average rate of change. In simpler terms, at some point, the slope of the tangent line equals the slope of the secant line. Let's look at the graph to understand this. We have a function from A to B. First, look at the straight line connecting the two endpoints. This is a secant line, and the slope of this line equals f of b minus f of a over b minus a. This represents the average rate of change over the entire interval. Now, look at the curve. Somewhere between A and B, there is a point where the tangent line has the same slope as the secant line. That point is labeled C. At that point, the slope of the tangent line, f prime of C, matches the slope of the secant line. So visually, what's happening is this. At some point, the tangent line is parallel to the secant line. If a function f is continuous on a closed interval from A to B and differentiable on an open interval from A to B, then there exists a value C in between A and B such that f prime of C equals f of B minus f of A over B minus A. The left side, f prime of C, is the instantaneous rate of change. The right side, f of B minus f of A over B minus A, is the average rate of change. So the mean value theorem is saying at some point, the slope of the tangent line is equal to the slope of the secant line, which means the tangent line is parallel to the secant line. Let's compare the two ideas clearly. The secant line slope is the average rate of change over the whole interval. The tangent line slope is the instantaneous rate of change at one point. And the mean value theorem guarantees that these two slopes are equal at least once. So to summarize, as long as the function is continuous and smooth, there will always be at least one point where the instantaneous rate of change equals the average rate of change.